Hey, so this week we are going to learn how to graph sine and cosine functions. All right, so what you're looking at right here is the completely expanded form of sine and cosine when you have all the transformations uh, included here. So um, we are used to seeing the letters A, H, and K. Um, and so the new letter here is B. Again, so the K is the vertical shift, H is the horizontal shift, which they're going to start calling phase shift now. A is the amplitude. Okay, it's going to tell you how high and how low this function is going. And B is the period function. So that's going to the period. This is going to be a new word that's going to be very important because trig functions, okay, the sine and cosine functions are periodic functions, which means that over a period of a given interval, the function just repeats. It goes up and then down, up and then down. We'll take a look at that and how fast it repeats, okay, is the period. So from where to when, okay, where does it start, where does it end? That's a period. And once it starts to repeat itself, right? So if you could graph one period, okay, then you could expand it out and do the rest of the graph. All right, so we are going to be looking at this information here. So if I pull up a graph here of sine of x, so f of x equals sine of x. So this is a periodic function. What do I mean again by periodic function? Is that this graph is up and then down, and then once you get here, right, it's back to where it began, then it goes back up again, back down, okay, and so it continues to repeat. So if I zoom out here, you can just see that it's constantly repeating the pattern. All right, and so where does that pattern start? Okay, where does that pattern end? Okay, so if we look at 0, 0, the origin, okay, because this is a parent function, okay, that's going to be our starting point. So it goes up, okay, at 90, it hits a maximum, then it comes back down and it hits 180. So is that one period? No, because it's not the same thing here. Now, if it went back up, okay, then it would have been a period, but it goes down, so it's different. And then it hits 360. Now, after 360, boom, now it starts to go back up again. Okay, so now you can see that there's the period from 0 to 360 degrees. Okay, so then it just continues to repeat. And if you look back on this way, it's the same thing over there. So you can see on the screen right now, there's two periods. Okay, from negative 360 to 0 is one period, and from 0 to 360 is another period. All right, and it just repeats. The more I zoom out, okay, you can see it over and over again. It never ends. The domain is all real numbers. Okay, the range, okay, would just be from -1 to 1. All right, and the period, okay, would be 360 degrees from 0 to 360, and then that period repeats. So it's continues on forever. We're going to show you how to write that period. It'd be plus, okay, in this case, every 2 pi or 360 degrees, it repeats itself. All right, so this is a sine function right here. This is called a periodic function. Okay, this is a periodic function. Okay, why do we call it a periodic function? Okay, because it has a set period where the graph repeats itself. All right, so that's what we want to make sure. Vocabulary word there. And again, where did that come from? Okay, that came from the B. The B is going to control the period. All right, so now I want to focus on the x-axis. This is a very confusing point when we first start to learn how to graph trig functions, is what are my inputs? So we got to think back. What are we doing the sine of? These are angle measurements. My input are angle measurements. And so we've learned over the past couple weeks, there are two different ways to represent an angle. One is in degrees and one is in radians. So what you're looking at right now is my x-axis is numbered in degrees. All right, so you can make sure when you're in decimal, if you're in degrees there, all right, and then you could set your x-axis from whatever you want. So I set it from negative 360 to 360, and then I made my step every 90 degrees, all right, because I don't want my steps to be 1, because then I would have to have 1, 2, 3, 4, 5, 6, 7, all the way out to 360 to see one period. So I'm counting by 90s here on my x-axis. So we want to be able to label and number our x-axis here. And so we did that. And if I look over here at this graph, now you can see how I numbered my axis in pi half. So now it's in radians. So if you go to settings, okay, I'm in radians mode. I made my window from negative 2 pi to positive 2 pi. And I'm going to put my steps at 1/2, which is, again, pi halves is just 90 degrees. Okay, so this exact same graph, okay, these two graphs are identical, okay, but one has the x-axis in degrees, and the other one has the x-axis in radians, okay? Radians is much more common, all right, than degrees, right? Because you got to think about, I mean, just what's pi? Pi is 3.14, so it's going to be easier to represent those numbers when we're talking about in terms of radians as opposed to in terms of degrees. All right, and so we want to talk about some of these. So if I come over here to the one that's in degrees, and I pull up a table of values for this, right? And so it automatically populates these x values. But these are degrees. This is -2 degrees, -1 degrees. Like none of these aren't very helpful. Now zero is helpful, but the other like 1 degree, 2 degree, 3 degrees, those aren't very helpful, right? What are my degrees that are helpful? All right. And so that's why we spent so much time with the unit circle here. These degrees are helpful. 30 degrees, 45 degrees, 60 degrees, right? These ones are helpful. So when we use a table of values, okay, we're getting the stuff from the unit circle. So, right, if I go here, I'll start at 0 degrees, and then I could go 30 degrees, and then I could go 45 degrees, 60 degrees, okay, 90 degrees. So you can see these points start to populate over here, right? We know that sine of 30 degrees is 1/2. That's right from the unit circle. Sine of 30 degrees, we're talking about the y values here, okay? And then you come back. So sine of 45 is rad 2 over 2, but that's just 0.7, right? And then rad 3 over 2 is 0.866, and then 90 degrees is 1, right? And then it's going to start, okay, to repeat itself. Okay, so if I go 120, that's the same as 60, right? 135, that's going to be the same as 45, right? And then 150 should be the same as 30, okay? And then 180 is going to be 0. So you see all these points start to populate on the graph. So I'm inputting in degrees, all right? And so for the unit circle, what's always going to be the largest value of y, right? The largest value of y is 1. Right? So these functions are never going to be higher than 1, okay, unless I add an amplitude, a number in front, an a that's going to stretch it out to make it grow higher, okay? And so when I'm looking at the unit circle, right, some of these numbers aren't very helpful. I mean, rad 2 over 2 is not very helpful. It's it's your 0.7 decimal. Rad 3 over 2 is your 0.86 decimal, right? But at 90 degrees, right, at 0, 90 degrees, 180, 270, those are helpful numbers. Those are nice, easy integers, okay? Even the 1/2s are helpful. They're at least they're easy enough to plot on the graph, okay? So I would also want to do 270 degrees, okay, and then 360 degrees, okay? And so you can see these points start to populate on the graph here. And these are in degrees, okay? But again, like I said, the more common way to do this is in radians. We want to make our x-axis in radians, all right? And so for a sine function, for a cosine function, okay, how do I know what the period is going to be? Well, the period is one trip around the unit circle for sine and cosine. All right, it doesn't start to repeat itself because it's right. All the y values are positive here, so my signs are positive, then my signs are negative. For cosine, right, it's going to go positive, negative, negative, positive. So it's going to it's going to be shifted over a little bit, and we'll take a look at that in a second. But a period is just one trip around the unit circle. All right, and then after that, it repeats itself, right? Because we go around, that's 2 pi, right? And now we're at 13 pi 6, which is the same as pi 6. So all the stuff starts to repeat itself. All right, that's the nice thing about periodic functions is everything just repeats itself. Okay, so looking at our graph where the x-axis is in radians, okay, how do I know to put pi halves, pi, 3 pi halves, and 2 pi here? Well, if we know the period is 2 pi, okay, we just want to cut that into force. Okay, that's our shortcut. Our force, okay, around is going to get us at the max, okay, at the x-intercepts, okay, at the mins. So that's what we did. We just cut 2 pi into force, and that's how we knew what to label it was. Okay, if the period was condensed, okay, which we're going to talk about in a couple weeks. Okay, so real fast, right? If I threw a 2 in there, now the period is condensed to just pi. You see that period? It's reduced. It starts to repeat after pi now. Take out the 2, right? The period doesn't repeat until 2 pi. Okay, put in the 2, right? Now it goes from 0 to pi, and then it repeats itself. What if I make that 4? Okay, now it's going to go from 0 to pi halves, and it's going to repeat itself. But there's critical points that we want graphed. We want the maximum, we want the minimum, we want the x-intercepts. Okay, and the beautiful thing about sine and cosine functions is that those will always be, okay, at a fourth of the period. So whatever the period is, we know it. So like right here, we got pi eighths, pi fourths, 3 pi eighths, pi halves. We took pi halves and we divided them into quarters. Okay, so that's one way of doing that. Okay. So again, our x-axis is in radians, okay, and we cut the period into force to know which points we want. Okay, so my table of values, okay, what am I going to type in here for my x values? Okay, so 0, all right, and then I'm just cutting my period into force. So if the period's 2 pi, then I want pi halves, no pi, no 3 pi halves, and I want 2 pi. And so you can see now those points, all right, match up with my max, my min, and my x-intercepts. So if I just change this to cosine x, what's that going to do? Well, at 0 now, okay, the x value is 1, right? So for cosine, it's the x value. So when you plug in 0 degrees or 0 radians, now your output is 1, right? You plug in pi halves, your output is 0. All right, and so you can see here, here's my new table of values, taking the points from there. Okay, this is cosine. So what's the difference here? So let me just type in sine down here. All right, and so you can see it's almost the same graph, okay, but one is starting at 0, 1, the other one's starting at 0, 0. All right, they both have a period of 2 pi. Look at the red graph here, right? At 0, it's 1, then back at 2 pi, it's 1. It got back to the beginning point. So lots to recognize here, okay, with this graph. So let's just, okay, ask you guys a couple questions here about period. Okay, so erase one of these here. So right now, for this graph, cosine x, what is the period here? Okay, is it 0, is it pi, or is it 2 pi? All right, and you answered that one. Okay, what about for this function? Cosine 2x, what is the period here? Okay, is it 0? Is it pi halves? Is it pi? Is it 2 pi? Okay, what is the period here for cosine of 2x? All right, and then cosine 4x, what is the period here? Is it 0? Is it pi quarters? Is it pi halves? Okay, is it 3 pi fourths? Is it pi? Okay, what is it there? And let's jump to sine. What is the period here for sine x? Is it 0? Is it pi halves? Is it pi? Is it 3 pi halves? Or is it 2 pi? All right. What if I throw in an 8 here? Okay, what is my period now? Okay, is it 0? Is it pi eighths? Is it pi fourths? Is it pi halves? Okay, what's going to be my period? All right, and so the one thing that you notice here about all these, now that we've talked period a little bit, is that no matter what I do with my period, I make that, what is my maximum here for all of these? Doesn't matter if it's sine, doesn't matter if it's cosine, right? The highest point is always 1. That's because that's my amplitude. Okay, so if I just threw a number in front, making my amplitude 2, what does that do to my maximum? What's that do to my minimum? Right? The altitude is the distance, right? Okay, from the midline, so halfway through the wave to its high point and then to its minimum. Okay, so the altitude, okay, is, here's the midline. Okay, it's not very neat, but, and then the altitude is this distance here. That's my altitude too. So if I just change that real fast, okay, I'm gonna have to make my altitude bigger here. Now my altitude is 4. Okay, because I made my A 4. Does not change my period. My period is still 2 pi right here. All right, but the A is going to change my altitude. Okay, the B, when I say the B here, okay, when I say the B, going back to this screen, right, this B right here is going to change my period. All right, H and K is going to shift it left and right, up and down. We're going to talk a little bit more about that this week. Okay, so to recap, we need to know that sine and cosine functions are periodic functions, okay, meaning that after a certain amount of inputs, the function just starts to repeat. All right. We need to know that the x-axis represents an angle measurement. Okay, so here on this example, it is in degrees. Okay, but we want to be able to do it in radians. Radians is more common and more useful. So we're going to make sure that we label our x-axis in radians. All right, and we could just, whatever the period is, how do you know what to number your x-axis? Okay, the shortcut is whatever the period is, it's just you divide that into force. All right, and that's going to be your, what you number, you really want to identify, because that's going to get you your maximums, your minimums, your x-intercepts there. All right, so hopefully we are going to build off of this and continue to graph. We're going to start with parent functions during block 1. Okay, and you guys could get a good look at really understanding the periods and amplitudes. Okay, and then on Tuesday or block 2, you'll get a look at the shifting up, down, left, right. Okay, and then really changing the periods. All right, so let's have a great week.